Hello all, welcome to the video lectures on part 3 of Unit 1 of Computer Networks and Security. In this session, we are going to discuss about the random access protocols of MAC layer. In the last session, we have discussed about the controlled access method and channelization techniques. In these few sessions, we will see the protocols, namely ALOHA, CSMA, CSMA-CD, and CSMA-CA. Let us again have a view of MAC protocols. We have random access protocols, controlled access, and channelization protocols. In case of channelization methods, there are dedicated channels. The channels might be in the form of various codes uniquely generated for the users, or time slots, or frequency bands. In case of controlled access protocols, some system or some station has the control to decide who should gain the access of the channel. In some cases, there are techniques like token passing, where whichever station has the token have the control over the channel. Here onwards, we are going to discuss about random access protocols. Now, what these random access protocols are? These are called as random access protocols because the stations that are on the media, that are using the same media, do not have a priority. For example, we have seen that there was a primary station and there are secondary stations. In case of random access methods, all the stations are with the same and similar authority. No station is given the priority to gain the access of the channel. And so, stations have to compete with one another. It is called as contention. So, stations compete with one another following some techniques or some methods for the channel access. And that is why it is called as random access, because any one station can win the competition and gain the access of the channel. We are now going to see how these random access protocols work. The first protocol is ALOHA. ALOHA is the name given to a protocol which is with the bare minimum assumptions. In ALOHA protocol, by the way, ALOHA means hi in some language. So in ALOHA protocol, there is no mechanism. The only method is if and when the station has the data to send, it will send the data without checking whether anyone else is sending or not, whether channel is free or idle, whether channel is free or busy. Stations will send the data as and when the data is ready with the stations. So you can see in the diagram that station 1 is sending few frames, frame 1.1 and frame 1.2. Station 2 is sending 2.1 and 2.2, and these are sent at random time. What happens is, in this shaded area here and here, you can see that some part of frame 1.2, the whole frame 2.1, some part, trailing part of 3.1, and whole frame 4.1. All are sent on the channel at the same time. And that is why the whole lot of data is collided and there will be unsuccessful delivery of the data. Rather, there won't be the delivery, data will be destroyed. So that is obviously the disadvantage. Same happens in this shaded region. Frame 2.2 and some part of frame 4.2 collide with each other, and then the data will be lost. There are few frames like frame 1.1 and 3.2 where no other station is sending, only these frames will be successfully delivered. But this is a rare possibility because we do not know exactly at what time which station will send, as there is no technique followed to check whether the channel is busy or free, or rather if someone else is sending or not. So this is about ALOHA protocol. Now on the next slide, we are going to see the whole operation of ALOHA protocol in the form of a flow chart, and the same flow chart with minute modifications will be used to understand other protocols as well. So this is the procedure which is followed by the stations. Start. Here on the left side, we have various parameters. We have K, which is number of attempts. We have TP, that is maximum propagation time. We have TFR, which is average transmission time for a frame. TB, which is back of time. Now we will see each one in detail. What is K? Number of attempts. Because in a case, if the data is lost, the data has to be retransmitted. So this is the number of attempt for that particular data frame. So initially we set it to 0 for the first transmission. K is equal to 0. Then we have maximum propagation time, which is equal to TP. What maximum propagation time is? Suppose there are various stations situated like this. Pardon my drawing. In this whole network, all the devices are connected through a shared media. Now this station and this station has the maximum difference between them. These are farthest stations. So time taken for the data from this station 1 to reach to station 2 is the maximum. And so this is called as maximum propagation time. That is denoted by TP. Average transmission time for a frame, that is TFR. Depending on the channel speed, we can calculate how much time is required to send one frame. It also depends on how many bits are contained in a frame. TB is a back off time. We will see eventually what back off is. Now let us start with the flow chart. So K is set to 0. Then now in ALOHA, whenever a station has the frame to send, it will send the frame. Frame is sent. It will wait for timeout time. Now this timeout time is for the acknowledgement. Unless the acknowledgement is received, the successful delivery is not guaranteed. And that is why station has to wait for an acknowledgement. Now for how much time should it wait? It should wait for 2 into TP time. Just now we have seen that maximum propagation time TP is time taken for the data transfer between stations which are farthest in the network. So suppose now this station is sending data to this station. For how much time this station should wait for the acknowledgement? This is one time TP. Data reaches there, 2 will send an acknowledgement, and time taken for the acknowledgement to reach 1 is also TP. So sending TP and acknowledgement TP makes it 2 into TP. So for 2 into TP time, the sender has to wait. Now check whether acknowledgement is received or not during this timeout time. If yes, then obviously the delivery is successful, transmission is successful. But if acknowledgement is not received, there are various possibilities. Probably data is with error, or probably acknowledgement is with error, or another case is acknowledgement is completely lost. So in any case, we consider that acknowledgement is not received, and then the data has to be retransmitted. For retransmission, the number of attempt has to be incremented by 1. Now, for how many times you can retransmit a frame? For that, there is a limit. Usually, the limit is set to 50. That is, after first transmission, if it is unsuccessful, 15 more times the data frame can be sent over the channel. So here, after incrementing K, it will check, the system will check whether it has crossed the maximum limit. If yes, then the transmission is aborted. The frame will not be sent again. If maximum value is not yet reached, we still have number of retransmissions left, then we choose a random number r between 0 and 2 raised to k minus 1. Now the significance of this 2 raised to k minus 1 will be explained later on. Here, after choosing to retransmit, the station has to wait for back off time. It has to back off for some time. You know, you understand the meaning of backing off. It will refrain from sending. It will not immediately send. It will wait for some time, and that time is equal to R into TP or R into TFR. In general, this time is random because this R is a random number between 0 to 2 raised to k minus 1. Only thing is that this R is proportional to the k. That means how many times we are sending the data. Sorry, the number of retransmission is considered as k, and R is directly proportional to k. Now, after waiting for TB time, that is back off time, the system or station has backed off for a certain amount of time, and after that it will again send the frame. So this is the whole procedure of ALOHA protocol. Let me remind you, ALOHA protocol doesn't use any technique before sending the frame. Whenever the station is ready with the frame, that will be sent over the channel, and due to which there is a possibility of the collision, and the possibility is highest in this case because there is no check. So now let us proceed to understand few more parameters for pure ALOHA. This is called as vulnerable time in pure ALOHA. That means the time in which there is a possibility of collision. This vulnerable time is nothing but sensitive time, we can say. During this time, we can have the collision. Take an example. Station A has sent the data during this time t, and this is t plus TFR, because suppose this is the frame transmission time, that is time required to send the complete frame. Now, if at all, after time t, suppose someone sends the data, that means after t minus TFR, if B sends the data, trailing bits of B's frame are going to collide with A's frame. Similarly, if station C starts sending before t plus TFR, then initial bits of C are going to collide with A's data. So in this case, for successful delivery of A's frame, nobody should send after t minus TFR and nobody should send before t plus TFR. So time t minus TFR to t plus TFR is vulnerable or sensitive time, which makes it 2 into TFR. So this is one frame transmission time. This is another frame transmission time. It makes it 2 into TFR. And so this is vulnerable time. Using this vulnerable time, now what we can do is we can calculate the throughput of ALOHA protocol. So throughput for pure ALOHA is is equal to G into e raised to minus 2G. What is G now? G is average number of frames generated by the system in frame transmission time TFR. So during TFR, how many frames are generated is nothing but the value of G. And please understand, this G is considered for the whole system. The system might contain one station or 1000 stations. The average number of frames generated by all the stations in one frame transmission time is nothing but G. If we substitute certain value, the maximum throughput will be 0.184 when G is equal to 0.5, that is 1/2. As you can observe, the maximum throughput of the ALOHA protocol is 18.4%. 0.184, that gives us 18.4%, which is very less. And so ALOHA is the protocol which is not used in practice, but this was the basic protocol which was designed with lot of assumptions. The another protocol is slotted ALOHA. This is a betterment or improvisation in ALOHA protocol. Here, the time is divided into various slots. As you can see in the diagram, time is divided into slots, and the stations can send the data only at the beginning of the slot. So here you can see station 1 has frame 1.1, frame 1.2. Both the frames are sent at the starting point of, say, slot 1, and in this case slot 3. Similarly, station 2 is sending in slot 2 and slot 4, and so on. What happens here is, even if the stations, still there is a possibility of collision, because at the start of a slot, 2 stations can send simultaneously, like in this case. Station 2 and 3 are sending at the same time, so these 2 frames will be lost, certainly. But what happens is, even if the station has data to send at this time instance, it will have to wait for this much time for the start of new time slot, and at the beginning of new time slot only the frames can be. Due to this, the vulnerable time of the slotted ALOHA technique is reduced. I think you have got an idea why the vulnerable time might be reduced. Here, the vulnerable time is exactly equal to TFR, because nobody is sending after T minus TFR randomly in between at any time instant. Nobody will send the data. Before T plus TFR also, no one will send. They will be able to send the data only at the beginning of the time slot. If 2 stations send the data exactly in the same time slot, they will get collided and the data will be lost. Still, the protocols are not foolproof, but it is better than the ALOHA protocol. Now here the sensitive time or vulnerable time is reduced to TFR. So it is half of pure ALOHA protocol, and due to which the throughput of slotted ALOHA is double than the pure ALOHA. So maximum throughput when G is equal to 1, the throughput is 0.368, that is 36.8%, which is exactly double of pure ALOHA protocol. I hope the idea of pure ALOHA and slotted ALOHA is clear to you. Pure ALOHA, in pure ALOHA, stations send the data whenever the data is ready with the stations without checking any condition. In slotted ALOHA, even if the data is ready with the stations, stations will be able to send in at the start of next time slot, because time is divided into specific slots. In this video, you need to understand, you need to remember the flow chart of pure ALOHA protocol, the parameters that we discussed, like K, which is number of attempts, TP, that is maximum propagation time, TFR, frame transmission time, and TB, which is back off time. Then we have seen throughput, or we have seen the formula for throughput of the pure ALOHA and slotted ALOHA protocols. Here is a question for you. Try to solve this problem. A slotted ALOHA network transmits 200-bit frames on a shared channel of 200 kbps. So channel speed is given as 200 kbps and frame size is given as 200 bits. What is the throughput if the system, that is all the stations together, produce 1000 frames per second? Please try to solve this problem. We have come to an end of this session now. In next session, we will discuss about the next technique, which is called as CSMA technique. Thank you.